Hello everyone, and welcome back to the Python OOP series. In the previous videos, we've been exploring dunder methods and learning how Python allows us to customize the behavior of objects. Today, we're shifting our focus from classes to functions. We're going to learn one of the most important and powerful features in Python, decorators. Decorators allow us to add functionality to existing functions without modifying their source code. This concept is used almost everywhere and especially in professional software development projects in Python. Logging, authentication, performance monitoring, API routing in FastAPI, and many other important features rely heavily on decorators. By the end of this video, you'll understand what decorators are, why they exist, and how they work under the hood. So let's get started. Now, before we talk about decorators, let's quickly recap. In the previous videos, we learned that Python allows us to customize object behavior through dunder methods. For example, len calls the dunder method on len. Indexing also calls the dunder method getItem. And there are multiple other dunder methods used in Python as well. Those special methods allowed us to customize classes. Today, we'll learn how Python allows us to customize methods or functions. Now, let's imagine we're building a backend application. We have multiple functions: create user, delete user, update user, etc. Let's have a look at this in code. Now, this is exactly the same three functions we had in our presentation. At first glance, everything seems fine, but notice something. Every function contains the logging print or the logging function which can be implemented later. Now, the same code is repeated in all the three functions. Now, let's say we have 50 functions or 100 functions, or let's say we might even have 500 functions. What happens if we want to change the logging behavior? We'll have to go and update every single function. This kind of repeated functionality is called cross-cutting concern. Now, examples included are logging, authentication, performance monitoring, validation. Decorators were designed to solve exactly this problem. So, what exactly is a decorator? A decorator is a function that takes another function and adds extra behavior to it. The original function remains unchanged. Instead, the decorator wraps it. Think of it like wrapping a gift or a parcel. The gift itself doesn't change. We are simply adding another layer around it. In professional software systems, decorators are commonly used for logging, authentication, authorization, timing, input validation, and API routing. The key idea is very simple: add functionality without modifying existing code. Now, before decorators make sense, we need to understand something important about Python. Functions are first-class objects. This means that functions can be treated like any other object. Let's see an example. Now, we have our three functions. Let's say update user is equals to, no, let's not say update user, let's just say update is equals to update user, or let's just say update user. And now if we go update user, or not update user, update, and if we run this code, let me open my terminal, new terminal, this up, python main.py. As you can see, the update user function has been printed. So what happened here? We assigned a function to a variable, then called it through that variable. This works because functions are also objects, just like strings, integers, lists, dictionaries, etc. This idea is one of the foundations of decorators. Now, since functions are objects, they can also be passed as arguments. Say we make another function. Let me remove this. Let's say def, and let's just call it a func1, and let's pass update user here. And if we go update user, no, let's not say update user, let's just say func here, and let's just call our func here. Now, in func1, if we pass update user, let's see what happens. Let me clear this. Let me run python main.py again. As you can see, update user has been printed again. Now, notice something important. We passed update user, we just passed update user, not this. We did not pass the parentheses. There's a huge difference. Update user with parentheses executes the function immediately. Update user without the parentheses passes the function object itself. The execute function receives that function and calls it later. This ability to pass functions around is exactly what decorators rely on. Now, let's build an actual decorator. Now, let me remove all of this. Let me pull my terminal down. And let's build a decorator called my decorator for simplicity. And let's pass a function. Now, we will have a wrapper, just like GIF wrappers. And let's print saying before execute our function and print after. All right. Now, after this is done, let's go back to the first function and return wrapper. All right, let's break this down. The outer function receives another function as an input. Inside, we create a wrapper function. The wrapper adds behavior before the original function runs. Then it calls the original function, then adds behavior afterwards. Finally, the decorator returns the wrapper function. This is the core structure of almost every decorator you'll ever write. Now, let's see this in action. Let's create a function saying say hello, and let's just print hello ML orbit. All right. Now, let's create our decorated run. Decorated is equals to my decorator. And let's pass say hello without the parentheses, specifically without the parentheses. And now if we call decorated, let's see what happens. Let me open my terminal again. And let's print python main.py. All right. We got before hello orbit, hello ML orbit, and after. Notice what happened here. The wrapper gained control of the execution flow. It executed code before the original function, then it executed the original function, and at last it executed code after the original function. This is why decorators are so useful. They allow us to inject behavior around existing objects or functions. That's how logging decorators, timing decorators, and authentication decorators work in production systems. Now, it is very important to understand the @ syntax as well. Manually decorating function works, but Python provides a cleaner syntax. Let's look at a manual version. Now, we have our say hello. We have our function. We have our object as well called decorator. Let's rename this to say hello. And let's remove this. All right. Now let's look at the modern version. Instead of this, what we can do is we can simply call my decorator and then write our function. So let's remove all this, add our decorator, add my decorator, and then, yeah, so this is it. So these two examples, so this example and the previous example, which is this, is exactly the same. The second version is simply cleaner and easier to understand. It automatically performs what we were executing previously behind the scenes. This is the exact syntax you'll see in real projects and frameworks like FastAPI. Now let's try and run this. Let's call, let's print say hello and see what happens. Yeah, as you can see, before hello ML orbit and after have been printed. Yeah. Now let's quickly recap. Decorators allow us to add functionality to functions without modifying the original code. They solve cross-cutting concerns such as logging, authentication, timing, and validation. Decorators are possible because functions are first-class objects in Python. Functions can be assigned to variables, passed as arguments, and returned from other functions as well. A decorator wraps another function and adds behavior before or after execution. And the add decorator syntax is simply a cleaner way of writing functional reassignment. In the next video, we'll learn how to write production-ready decorators using args, keywords, arguments, function tools, wraps, etc. We'll also build timer decorators, debug decorators, and retry decorators that are used in real software systems. Now, I know this video is a little hard to understand, but if you found this video useful, make sure to like the video, subscribe to the channel, and let me know if you found anything a little vague or if you need any help. I'll always reply to the comments, and try using decorators on your own. Thank you for watching, and I'll see you in the next one.